Alright, it's officially filming. We'll forget it's on eventually. That'll be weird. Alright. So today we get to take a little break from like the mechanics of derivatives and talk a little physics.
That makes 3 periods of physics today.
So the good thing is you might actually find this really easy. Who's not in physics? That's a lot of you. Okay, who hasn't taken physics like 1 or AB or whatever they call it? B. So never taken physics before. Anyone else never taken any physics before?
I'm currently taking physics.
And currently. Okay.
The first one.
So you're going to be in a totally different area than the people who have it. The people who have physics and are taking physics C, you guys should probably find this stuff potentially very easy. I will tell you right now, I suck at it. I hate physics. I do. I hate it. I think that it's cool for its use, but it's not my strong point, so whatever. So, what you need to know about physics is, when you look at the top of this page, we have one main function that we start with, and that's the position function. And a position function, we use the letters s of t, or in physics, what do you guys use? X, okay? So in physics, you often use x of t to equal position. And position literally is talking about where something is. So like, if you did a parabola, you threw a ball, and there wasn't like wind resistance or any of that stuff, you threw a ball off of a 400-meter cliff, you know, what was the velocity at such and such, or what was its position after 2 seconds? That's like the beginning of physics, right? Kind of. Like first year physics, easy stuff. So that would be a position function, and you could plug in 3 seconds and it would tell you how high it is, and 4 seconds it would tell you how high it is. Well, if you take the derivative of position, you get velocity. So velocity tells you how fast something is going, correct? And it tells you its direction also, right? So a lot of times these problems will say a particle is moving along the x-axis such that its position function is whatever. What's its velocity at such and such a time? So we'll be taking a derivative, we'll be plugging into velocity, and that'll tell us whether we're moving to the right on the number line or you're moving to the left on the number line. So that's a very basic calculus question, but they ask it a lot. And then we're also going to have ones like the one down here we'll get to in a second. All right, in addition, the second derivative of position, or the first derivative of velocity, is acceleration. So that's telling you how fast your speed is changing. So big thing, derivatives are talking about rates of change. So if this function is position, and I want to know how fast is my position changing, that's a rate, that's a velocity. So at what rate is this changing? That's its velocity. At what rate is the velocity changing? That's its acceleration. And then there is one more, but we never really talk about it. I said this the other day. Oops. And that's called jerk. And we don't really talk about it because it gets kind of confusing. But jerk is like how fast your acceleration is changing. So that's like when you're on, a roller coaster ride, your acceleration changes, like is going at one speed and then it changes quickly. You get that like jerky feeling. That's what that's all about. But we don't really talk about that much. Or that's what makes your coffee spill when you're driving or makes you feel car sick. Blech. Okay. Example 1. Pretty simple. A dynamite blast propels a rock straight up with a launch velocity of 160 feet per second. It reaches a height of s equals blah 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 feet after t seconds. How high does the rock go? So, let me start with this. Okay, so you're being told the position function. A lot of times in physics you have to write it yourself, I think, right? And like, that number in front of t squared, isn't that like the gravitational pull due to gravity or whatever? I mean the pull due to gravity, and isn't it like 32 feet per second squared or something? Or it's, what's the equation? 9.8 the reason why this is 16 is because I've already taken half of it, because isn't the main equation like 1/2 something something? Okay. That doesn't really matter to us anymore because they're always going to give it to you, so you don't actually have to remember what the acceleration is due to gravity and all that stuff. Just, you'll see that connection, that you'll see 16 in here, or you'll see whatever half of 9.8 is in there, and that'll be where that came from. So anyway, but a lot of times it'll be like a problem on a moon, so the gravitational force on Earth won't matter anyway. Okay, so if this is our position function, what I do when I do these problems is I just go find the others right away. I go find velocity and I go find acceleration. Because if I have them, then I can go answer all the questions and work with the formulas that I already have, and I don't have to worry about derivatives anymore. So if that's position, velocity is just the derivative of position. So it's going to be 160 minus 32t. And acceleration is the derivative of velocity, so it's going to be negative 32. Just in general, for like non-physics people, position is like this many feet. Velocity is a certain amount of feet squared. No, I'm sorry, feet per second. What am I talking about? Feet per second. And acceleration is feet per second squared. What does feet per second squared mean? I have no idea.
Changing velocity over time.
Is that, so it just gets, because velocity already has a time in it, there's like 2 times in there, is that how that works out?
Yeah.
Okay. So whatever, that's like the label on it. So because this velocity is already feet per second, so you get 2 per second. Okay, that makes sense. Okay, so first question, how high does the rock go? We have a couple of choices with this. If you want to know how high the rock goes, I want to know, like, when does this have a maximum? When does my position get to the highest amount? We don't have a great way to find the maximum other than to like graph it. We could graph it and try to find its max. But what else happens when something goes as high as it's going to go and then comes back down? What happens at that high point?
Stops.
It stops for a second. For a split second, not even for a second, but for a split second, it stops. So if I want to know how high it goes, I want to find out when does it stop for that split second. Well, velocity is what's measuring its speed or how fast it's going. So if I want to know when it stops, I want to find out when is the velocity 0. So as you start to go through these things, you'll start to think about what it actually means. Well, if I want to know how high does it go, I want to know when is the velocity equal to 0. So all I have to do now that I have these equations is take the velocity and set it equal to 0 and solve. Always be aware of what they're asking you. So if they're asking you when, I'm looking for a time. If they're asking how high, I'm looking for a foot amount or a meters amount. So it's just important to know what they're asking you so you know how to answer it. So whenever we subtract 160 and t equals 5? 5 seconds. So this thing is going up for 5 seconds. At 5 seconds it's at its highest, then it's going to come back down. Alright, part B. What is the velocity and speed of the rock when it is 256 feet above the ground on the way up? Yeah, what?
How high does it go? We said 5 seconds.
Oh, sorry. Read the question. How high does it go? Okay. Does not go 5 seconds high. What do I do with that? I plug it into position. Okay, so sorry. At 5 seconds is when it's at its highest. Now I gotta find how high is it at 5 seconds. So plug 5 into position. That'll tell us how high. And I don't have the answers down. You can use a calculator for this because it's just silly to plug it in by hand. And when anyone gets it, just yell it out. What is it?
400.
4 what?
400.
400 flat unit.
Don't believe that.
It is Mike.
Yeah. Is it?
Yeah, it's 400.
Thank you. I don't know this newfound math that you're doing. Crazy. Okay, part B. What is the velocity and the speed of the rock when it's 256 feet above the ground on the way up? So what is the velocity and speed? I forgot to talk about speed. It's up at the top. We'll get there in a sec. Okay, so what is the velocity? Well, it would be nice if I could just plug a time into my velocity equation and tell what the velocity is. But I don't have a time. It's asking me what's the velocity when it's 256 feet up. Well, I can figure out when that happens by looking at the position function. And I can take the position function and set it equal to 256 feet and solve for the time. Because I don't know what time it's happening at, but if I take the position and set it equal to 256, that's going to tell me when the thing is 256 feet high. So this would be a calculator problem too. So I don't want to go through all the math and do this with these huge numbers. How would you do that quickly on your calculator? Here's what I would do. What's that? Did you say intercepts?
Yeah.
Yeah, that's what I would do. So if I was going to do this, like try to do this quickly, I would graph it. I would graph y equals 160t minus 16t squared minus 256. Doesn't matter if I have it in descending order at all. It just matters that I have everything on one side. And once I graph this, I'm going to find the zeros. Okay, so I'm going to find out when this hits the x-axis. And there are potentially two answers. Because it's quadratic, there's potentially two answers. Do I care about a negative answer? No, I'm solving for time, right? So since I'm solving for time here, all I care about is the positive answer. And in this case, is anyone doing it? I have 2.8 written down. But I didn't check myself.
Wait, you should actually have two positive answers.
Should I? I don't know. I'll check
I
it.
have because
Zero, or wait,
it goes
How
up
would you
and then
do
it
that?
comes down.
No, because you have a negative 256. One has to be negative for that to be negative.
Well, and wait,
Well, because the leading coefficient is negative, so it's, actually we can pull out a negative because it's negative 16t squared. In front.
yeah, wait, it should be
Then you
two
still
answers, shouldn't it?
Yeah.
And then
there's
it's
two
like a
answers.
negative.
Oh, never mind. I had 2, 8. Haha.
Okay.
Oh, that makes so much more sense.
There we go.
Okay.
So it happens twice, on the way up and on the way down. All of a sudden I was thinking that we were shooting this off of a hill or something, but we weren't. So yeah, it has to hit 256 meters twice, at 2 seconds and at 8 seconds. So it wants to know what's the velocity and the speed. Well, if I plug in 2 now into velocity, I got 96. And if I plug 2 or 8 into velocity, I got negative 96. This is feet per second, and this is feet per second. Is that okay so far? The speed, the only thing you have to know about speed is it's just, I wrote it up here, it's the absolute value of velocity. I don't know why they care or differentiate the difference between speed and velocity, but whatever. So speed is just the absolute value of velocity. So if they actually asked for the speed at 8 seconds, you would say it's 96 feet per second. So that does come up on the AP test, and I don't know why they care. But speed is always positive. You take the absolute value of whatever the velocity is, and that's the speed. Okay? All right, part C, what's the acceleration of the rock at any time t during its flight? Negative 32 feet per second squared. We already found that. It was constant. It didn't change. And then question D, when does the rock hit the ground? So when does the rock hit the ground? This is actually pretty easy. It hits the ground when what happens? Position equals 0. And not when velocity is 0. When the thing hits the ground, the velocity is actually going to be pretty big, because it's going to be going pretty fast by the time it gets back to the ground. The velocity, it like shoots up, the velocity is going really, really fast, it becomes 0, and then it gradually gets faster and faster and faster until it crashes onto the ground. So when it actually crashes, it's going very fast. A millisecond after it crashes, it's going 0 again, because it's sitting on the ground. But right as it crashes, it's going very fast, so don't get that confused. So the last question is, when does it hit the ground? Well, it's going to hit when the position is 0, solve this either. I don't know why I didn't do my work. Like I'm a slacker. And you get t equals 0 and 10.
You could just double the tiny dotted A.
To the halfway point. True, because we started on the ground and we're ending on the ground, you can double it. So 10 seconds. Sometimes you start like 400 meters up and then it would be a little bit different to when it hits the ground, but yeah. Okay, for physics people, is this like super easy? Good. For non-physics people, does it make sense? Okay, good. All right, second page. That's a lie. Let's do the third. Let's do the other one first. Let's do example 3. Okay, the position of a body at time t seconds is blah, blah, blah meters. Bless you.
Bless you.
Find the body's acceleration each time the velocity is 0. Would you know where to start? So this is the way so many of these questions go. It's like they don't want to ask you something simple and straightforward. They want you to kind of take a circuitous route to get there. Circuitous, good word, right? So if the position is whatever, find the body's acceleration each time the velocity is 0. So what do I do to find the velocity? Take the derivative of position. So 3t squared minus 12t plus 9. And if I want to find acceleration each time the velocity is 0, what do I do with this? Set it equal to 0. Good. Set it equal to 0. Solve for t. This factored pretty easily. T turned out to be 1 and 3. And then what do I do with 1 and 3? Plug it into acceleration, which I didn't get yet, but I will. Acceleration is the derivative of velocity, so it's 6t minus 12. And acceleration at 1 and acceleration at 3 are easy. Acceleration at 1, I got negative 6 meters per second squared, and at 3, I got 6 meters per second squared. Is that okay? All right, fourth one. Love this question. Okay, a particle moves on the number line. So this is what I was talking. This you're going to see a lot. A particle moves on the number line. I don't know why a particle is moving on the number line. You know what's a shame is that the people watching this don't get to see my new shoes. They should get to see my shoes. Right? Sassy but yet work appropriate.
Jimbo likes new shoes. I like shoes.
Let's talk about Jimbo's foot fetish another day. Okay, 1, 2, 3, 4, 5, 6, 2. Okay, so you got to think about what this is asking you for. A particle is moving along the number line so that the graph below is a graph of the position of the particle as a function of time. So this is time, and this is how far in centimeters it's going. And so this is like an S of t. And we literally have like a number line, and you have a particle on it, and the particle's going left and right, and left and right. That's it. There's like no big dimension to this. It's just going left and right. So if this is the position, it means the particle's starting 0, or how should I say this? It's starting at 0 centimeters, whatever. At 1 second, it's moved 2 centimeters. From 1 to 2 seconds, it's not moving at all. The position's not changing. From 1 to 2, the position is changing a total amount of -4. and then the position is not moving at all, and the position goes down to -4. So the question is, when is the particle moving to the left, when is the particle moving to the right, and when is the particle standing still? Standing still is the easiest. When's it standing still? Yeah, all the flat parts, right? All the horizontal parts. So when's it standing still? They want an interval of time. So from 1 to 2, it's standing still, and from 3 to 5, it's standing still. Then there are just two things to worry about. We have increasing graphs and we have decreasing graphs. Bless you. Well, think about if this is position and the derivative of position is velocity. What's the velocity here? And not even what is it exactly, but positive or negative? Positive, right? Because I have a positive slope, the velocity is positive. Well, if the velocity is positive, that means it's moving in a positive direction. So it's moving to the right. So because the derivative here is positive, that means the velocity is positive and it's moving to the right. So whenever this graph is increasing, it's moving to the right. So from 0 to 1, and that's it. From here to here, the velocity is negative. So from 2 to 3, I'm moving to the left. And again down here, from 5 to 6. Get it? Alright, cool. And then part B is actually pretty easy. Graph the particle's velocity and graph the speed. So if I'm going to graph the velocity, I'll do it in green. What is the velocity here? We said it's negative, but what is it specifically? 2. It's got a slope of 2, up 2 over 1. So if I was going to graph the velocity in red, it'd be here. From 1 to 2, where would it be? 0, because the slope is 0. 2 to 3, it has this negative slope. It looks like it's -4. Is that right?
Yeah.
So it's down here. From 3 to 5, it's 0 again. And then 5 to 6, I think it's only -2. Yeah. So there's the velocity graph. I just graphed it on top. You'd probably graph it separately. And then how about the graph for speed? Flip everything to the top of the x-axis. So not everything gets a mirror image, but anything that's negative becomes positive. So speed's going to be in blue, it would be here, here, and then instead of here, I got to go all the way up. Here, and instead of here, I got to go there. So speed's in blue, velocity's in red, position, stuff. Okay, cool. I think the other one you actually would be fine with. Oh, here's a good one. Example 2, just for 1 second. Example 2, letter C. Actually, you know what? We have time. Let's try the whole thing, and let's go over it. Skirt at her mom's shop. Hey, Monica. I got this skirt at your mom's shop. I did. Her mom's shop sucks, though. Don't tell her I said that.